Hello, everyone. Welcome back to another episode of Adventures in Machine Learning. I am one of your co-hosts, Michael Berk. Ben is actually out today. He had some exciting news and is taking a few weeks off. And so it will be just me. And today I am joined by Ken Youens-Clark. He has spent a lot of his career in academia, but has recently switched over to bioinformatics. And I was wondering, Ken, if you could sort of introduce yourself and explain why you're famous.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
Well, I'm not sure if I'm famous, but my quick story is I graduated with an English degree a billion years ago and needed to figure out a way to make a living. Got into computers and programming, thought that was really cool. That led me into a bioinformatics lab in 2001. So I discovered this whole world of academia and research and this nexus of biology and computer science, and thought that was super fascinating. And that's basically where I've spent most of my career, most of it in research. But at the beginning of this year, I joined DNA Nexus, which is a commercial platform, cloud-based platform for enabling bioinformatics. And so along the way, especially during my time in academia, I got really interested in teaching. I really loved mentoring and working with junior developers. And I was really excited to get some classroom experience while I was at the University of Arizona, where I worked for several years and also earned my master's degree. And it was in teaching those classes that I started writing books. My first book, actually, I was on this podcast a couple years ago to talk about tiny Python projects, which was my first book. I used that in the classroom several times to just teach the basics of like how to write a well-structured command line program in Python, and also how to test it. Testing has become a crucial theme to all three of my books. My second one is called Mastering Python for Bioinformatics. I published that with O'Reilly in 2021, continuing the theme of like, here's how you use tests to write a good program and make sure it's reproducible, which is a crucial in science and research computing and bioinformatics. And I've really taken that forward. I use all the skills that I talk about in those books daily in my job, working for some rather large customers that we have at DNA Nexus. Just before I joined at the beginning of the year, I was able to finish up my third book called Command Line Rust. So all of my books talk about how to write programs at the command line, the Unix command line, and how to test them. And so I just took the same formula that I had used for 2 books in Python. I used it on Rust. And honestly, I used it to teach myself Rust. I used that experience. I was enamored of Rust, had played around with it for a couple of years. And I was like, you know what? I want to get serious. I want to really figure this language out and understand all the different ideas, for instance, about borrowing and pointers and things like that I'd never encountered in dynamically typed languages like Perl and Python that I'd used most of my career. So that was kind of my deep dive into Rust, and also continuing forward with using test-driven development to write command line programs, which I think is a great way to learn any language, just to write simple programs that you already understand the basics of. Like, for instance, in this latest book, you write an implementation of cat or head, which probably everyone has used a dozen times a day. So that's how I've gotten to where I am. Not currently working on any new books, mostly just trying to keep my head above water with this new job. It's quite a challenge.
And what are you doing in this new job?
I'm my title is Senior Solutions Engineer. It's a pre-sales role, but it's extremely technical. So my job is to for instance, take a customer's existing pipelines, analysis pipelines, and implement them in our platform. And a lot of times that's pretty simple because they're already probably using Unix command line tools. And so a lot of times we're just putting them into maybe a Docker container and then writing some Python or Bash to launch that and wrapping that up in our platform. But sometimes it's writing workflows from scratch. Like the customer has a basic idea, they want to take some sequencing data, they want to go through these QC steps, they want to do these cleanup steps, they want to do these analysis steps, and then at the end they want this custom output, which means I have to sit down and write a lot of linking scripts a lot of times to translate one format to another or run some tools. So and we use a lot of what's called a language called WDL, workflow definition language. So it's a high level language for describing the first step in a pipeline is this tool. It takes these inputs, it creates these outputs. The outputs from that tool can then be linked to the next step and on down. It creates a chain, and along the way you can implement basically kind of MapReduce ideas. So if you have like 100 files coming in, you can say scatter these over a bunch of nodes and take the outputs of those and reduce them in this step where you bring them all back together for some sort of analysis. So it's just a lot of data analysis and a lot of writing code and honestly writing a lot of tests. One of the longest engagements I've had so far was actually just writing bespoke Python code for a customer who didn't have in-house bioinformatics expertise. And so they came to us with a rough idea of some tool that they wanted written. And I just sat down and wrote it from scratch and put in, like 100 tests there to make sure that it works correctly. So that's pretty much what I'm doing. I'm a developer.
Awesome. You touched on several really interesting points, and please stop me if you've covered these in the last podcast. I wasn't a host a couple of years ago. I joined like 6 months ago. But what is your overall thought about how do you approach testing an application? Because there's this dynamic where you can test unlimited things and use all of your time to make sure that the sum function of a given language is working properly. But you can also just assume that, for example, sum and numpy.sum actually sums two numbers. So where do you draw the line between over testing and yet being confident in your code?
Yeah. There's definitely a lot of spot testing. Anything that I write from scratch, I try to be fairly exhaustive. My functions, there's an interesting book from Manning called 5 Lines of Code, which I think the general idea is that a function should be about 5 lines of code, which is maybe a little terse for me. I want a function to fit in a page, like probably 50 lines or less, but I'm fine with a one-line function. The simpler and smaller a function is, the easier it is to test and, exhaustively test. So if I'm writing something, I might take a large function, try to break it down into as many very small functions that have what I feel are exhaustive tests for those very, very limited ideas, and then piece them back together into something larger that's more complex. And, those tests, each piece should be orthogonal, right? So, fixing any one function has no effect on any of the other functions. It's interesting you brought up the NumPy sum, because I actually have run into some problems with that. Underneath it's implemented in C, and so it's susceptible to buffer overflow. So, if you get into extremely large integer values and you're using NumPy, actually in my second book, the Mastering Python, I specifically point out that if you're trying to create in this instance, I think it was the exercise where you're trying to find all of the possible DNA sequences that could lead to a particular protein sequence. And given as the protein sequence gets longer, the number of input DNA sequences gets exponentially larger, such that it's very, very easy to overflow an integer value in NumPy. And so what's interesting is actually in Python, Python's native integers are unbounded, except to your however much memory you have. So anyway, we talk specifically about that. But sum is a great function to talk about, because obviously you can't exhaustively test that. You can't add all the numbers in the universe. So you do have to just. And this was interesting with the Rust book. One of my reviewers was just he was just so amazing. And he really was able to say, well, we can use built into the language, for instance, the upper and lower bounds of this data type. So, for instance, a U32 or a U64, you can actually say, well, for this function, going up to the upper and lower bounds for this data type, does it work at the extremes? Does it work with stuff in the middle? It's quite a bit different with Python because obviously, we don't have that fine a grain of types. So I remember a CS professor telling me, for instance, if you're writing a function, try to handle like 0, 1, and then some number of stuff. And just like that idea has served me really well. So when I'm trying to write a function, I say, well, what happens if I pass the empty string? Or what happens if I pass 0? What happens if I pass a rather large number and then maybe something in the middle? And then probably that's good enough. But the crucial thing that I find, especially when I'm dealing with input data from a customer, so often, the input data is going to be like a CSV file, and you have an idea of the kinds of data that you're going to get for a particular column. You write a function to handle that column, and then it's working well enough, and then in production it breaks because they supplied a value that they didn't tell you they were going to supply. It was something you were unexpected. So what I will often do is take that value, put it into a test, prove that my function fails with that input, go fix the function, run the test again, prove that it now works with the new value that I wasn't expecting when I was developing this. And now going forward, I have a regression test. So I know I shouldn't fail when I see this value again. And so a lot of times my tests become this place where I accrue things that I wasn't expecting, and I use them just moving forward to kind of refine the code.
That's really interesting. So it makes the project development lifecycle a living, breathing thing that slowly grows over time. Have you also seen your knowledge base around testing increase throughout your career so that you write better tests? Or did you have it down by like day 2?
Oh, no. So just to go back to the beginning, I'm totally a self-taught programmer from the earliest days. I got a job as a technical writer. So I had an English degree. I can write a term paper, right? I was interested in computers, and I was playing around with like Microsoft Access databases and some really simple kind of macro programming. And a guy let me write a piece of software. He had written some software. I wrote a manual for it. Then he saw some potential there, and he taught me Visual Basic, which was the language that program was written in. And so I, for 20 years, really didn't do any testing at all. Like, no one sat me down and said, here's the proper way to write a piece of software. I mean, I was just Wild West, whatever worked, and I was writing code for customers. And it's just like, if it worked and they didn't complain, we moved on to the next job. I was mostly working on extremely small teams, or basically with myself, just me with a customer writing some code. If it worked, we moved on. It was really when I started teaching that I started really getting involved in testing. And I credit one of the worst students I ever had with making me a much better student, a much better teacher. At the time when we first started off, we were my boss, Bonnie Hurwitz, who hired me at the University of Arizona. We had been colleagues together at the Cold Spring Harbor Laboratory Research Institute, where we were working on like plant genomics databases, and we're good friends and stuff. And so she let me loose in the classroom. I was really excited about this. And at the time, we were both Perl hackers. Showing our age here, I really got into Perl in the late 90s because of web development, and then it took over in bioinformatics because it's so good at text processing. So we thought, this is like 2016, we thought, well, we'll just teach our students Perl. And I had no real method for teaching. I was just like, hey, I've got a dozen students here. Turn in a program. I'm just going to run them manually on the command line and see if they work, and I'll just give you a thumbs up. I was just basically looking kind of for pass-fail here for these students. I was teaching them from the beginning. I'm just like, give me something that kind of is in the ballpark. Well, this one student turned in code that didn't even compile. It wasn't even syntactically correct. And he was like, well, I get partial credit, right? Because, I turned something in. I'm like, no, that's not how this works. It doesn't even compile like that. And so I had to have an objective way to say, this does meet some minimum requirements. And so I just like, I have written tests before. I had written some CPAN modules and was trying to learn about proper software development. So I had gotten into testing a little bit. And so I started giving my students a test suite, a basic test suite. I said, here's how you run the test suite. And now you will know before you even turn it in if it works. Like whatever percentage of tests pass, that's your grade. If you passed 80% of the test, great. You got an 80. It's just black and white here. And so I started using that. And then I started realizing, if I actually show them the test one by one and say, like, here is what this test is expecting. Here's it actually, and I would order the test in a particular way. Like, first, your program has to exist and it has to be called this thing. Next, it has to actually print a usage statement. Next, it has to take an input value and do this thing with it. And so I was trying to use the tests in a particular way, and that they were ordered so that the students would have kind of a roadmap to how do I start the program and add features and get it to be where it does all the things it's supposed to do. So I got much, much better at writing tests for that purpose. And then I started like teaching, like, no, I'm actually going to teach them how to write tests and show them that this is a good way to learn how to break a large problem into many smaller problems. And then, it's kind of, so I'm a parent. I have 3 children, and I came across this quote years ago as a young parent. It said that setting an example for little children takes all the fun out of middle age. And it's true. Like, if you're going to ask your kids to eat vegetables, you've got to model that behavior. You've got to eat vegetables. You got to stop having a bowl of Captain Crunch right before bed, which I used to do, right? And just like, you have to model this good behavior. And so I started, like, everything I did, I was like, I'm going to have to write a test for this. And you just, I don't know, it just became just a part of almost my identity. Like, if I'm going to write a program, I'm going to write a bunch of tests. And I feel like that's what has made me become a much, much better developer and test writer and author and teacher. So yeah, I guess that's how I got to here.
Yeah. And I could not agree more that tests make you better in all areas of life. They help you modularize your thinking. One of the most impressive programmers that I've ever worked with, he doesn't write complex code. He doesn't write fancy code, but everything is so legible and so clean and makes so much sense, and therefore is super, super testable. So not only can you make sure that it will run reliably, but you also can understand it super quickly, and you can also add to it and edit it and change accordingly. So testing has been invaluable so far in my career. But I wanted to hone in. Sorry, go ahead.
I want to just make one analogy, if I can, to literature. So yeah, two of my favorite authors, and please, I have a wide range of authors, but I love David Foster Wallace and Ernest Hemingway, and those could be like red flags for some people because they were kind of problematic in many ways. Obviously, Hemingway is super misogynistic, but from a writing style, they're so diverged. Like, where David Foster Wallace will have like paragraph long sentences with footnotes, and the footnotes have footnotes, and it's just insane how convoluted. And but you really don't get lost in his sentences because they're so well constructed, but they're just so complex, and you're just in awe of how he can put all that there. And then you go to Hemingway, where it's like short declarative sentences, almost not even compound sentences, like, just so to the point and very clear. And I would say that my goal when writing code is exactly the way that you described your colleague. It's like short, extremely obvious functions. And one of the things I would say about tests is I like, when I can, I'll put the very short function here and then right below it, the test. And hopefully both of them together fit on the screen, and the test serves as documentation. So you can say, this function I can see takes this as input, this string. And when it's given this string, this is the data structure that it will return. That, in addition to using type annotations, which I do in Python, and then obviously you have to in Rust. I think type annotations, documentation, tests, they all lead to they can help lead to clear, simple code that is easy to understand and easy to refactor.
Yeah, that's a phenomenal analogy. Hemingway versus, that as like sort of a declarative analogy. I think he would be the declarative programmer in English, I feel like. But I was really curious. One thing that you brought up about grading was really interesting, which was you were trying to grade programmers based on an objective yes, no. And your default was essentially a pass fail. And when someone didn't have something that compiled, that it fails. How did you go from such a creative field as English, at least on the more fiction artistic side, where there aren't super hard and fast rules. How did you go from that creative world over to the very declarative Boolean world of programming? How was that transition?
I found it easy, not easy. I mean, programming is not easy. It's not easy to learn, but it fits the way that I think. I think I really missed an opportunity to study mathematics too in college. I think that, I got through calculus in high school and took the AP exam and was able to just not take math in undergrad because I was a Bachelor of Arts. And so, at most I would have had to, I think, pass algebra 2, right? Which I finished in like 10th grade. So there's something about the way that I think that coding, it comes more easily to someone who knows how to use language, maybe, than necessarily mathematics. But having a strong language background, and then if I have over the years been trying to learn more mathematics, more the rigorous computer science underneath of what's going on, but I still feel like I approach coding from like, how expressive can I be? How obvious can I make this? Like, obviously choosing good variable names, choosing good function names. I actually really, really rely on functional programming style, so that it's a lot of times it'll be like, map this list through this function. And if you understand map, then you just kind of understand you're applying the function to each element, and then you're transforming like that. Or filter through wanted, the function wanted this list of values. And so I feel like when I read my code, it's like, oh, this reads like a little English sentence, this. And so, and that was actually, I think, something that maybe attracted me to Perl for so long. Larry Wall, the creator, is a linguist by training, and he had a lot of ideas about bringing linguistic ideas to the expressiveness of Perl, which I think also leads to a lot of gotchas. Over the years, I started understanding how easy it was to misunderstand Perl, just as it is easy to misunderstand English, especially in the written form. So I see a lot of corollaries between language usage and writing code, even very formal code. And maybe I should also clarify that a lot of the programs I write are very short, on the order of hundreds of lines of code in a particular, script. So I wouldn't classify myself up there in the upper echelons of super complex coders who probably have a far better understanding of like memory management and like caching and all the stuff about computer engineering. I really have no clue how those things happen. I've strictly avoided languages like C, C++, Java my whole career. I've relied more on dynamically typed languages like Perl, Python, JavaScript, Bash. And so maybe there's something there where I'm happier. I'm okay with the kind of the ambiguities that are present in those languages. Maybe they're closer to natural languages in that way. I don't know. Maybe at this point I'm just rambling, but I do think that a humanities and a classics background is a strength in a STEM field, because writing code is one thing, but writing code that other people can understand, writing code that is documented, getting your ideas across, those maybe are soft skills, but they're extremely important to succeeding in this career, as important or more than just being able to write good code.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
Yeah, could not agree more about bringing different fields into the technical realm. Oftentimes, you need to work with humans and you need to build stuff for humans. And having not just a math background or not just a computer science background allows you to come at things from a different angle and problems from a different angle. And I've at least found that having a diverse team really leads to cool solutions and cool discussions. I haven't ever worked with someone that came from an English background, though, so that one day.
I would point out, actually, I graduated with an English background. I started as a music major. So,
oh, wow.
And I was a drummer. I started as a jazz studies major at the University of North Texas. Bounced around. I changed my major several times. I really had no idea what I was doing in life. No direction. Never took a CS class in undergrad. Just took a bunch of humanities stuff, philosophy, religion, and never thought that I would become a coder. So, and actually, it's funny. I've had a lot of music friends who either just kind of gave it over for technical kind of stuff like web development, a graphic artist, or, systems. And my roommate from college was also a music major. He actually finished with a jazz studies degree, phenomenal drummer, and he's mostly like a Unix sysadmin nowadays. So I think that there's a lot of, I think the formality, especially of music, we think, and especially in jazz, like if you're classically trained and you understand music theory, we talk about the form of a piece of music a lot. Very common in jazz to have like AABA kind of stuff. Talk about like, oh, this is a rhythm changes song, and that immediately tells you like a billion things you need to know about a particular piece of music. In classical, we talk about sonata form or concerto form and things like that. And so structured thinking like that, I think, really lends itself well to thinking in code, where you say you want to modularize things. Like, just like you said, you want to write a function for this. You don't want to repeat this idea over and over again. We do the same thing in music. If you've ever written out music and you're going to repeat 4 bars, there's no way you're going to want to sit there and write out the same 4 bars again. Instead, you put repeat marks, or you bracket it in repeat marks and say, repeat this twice, repeat this 4 times. I mean, my God, we're in a hurry here, right? And it's the same thing when you're writing code. Like, you're not going to copy and paste this code all over the place. You're like, oh, no, that goes in a function. Oh, and while I'm at it, I'm going to write a test here, and now I'm done. It's so much simpler it simplifies your code, really. That's what I'm trying to get at. That was like a real inflection point in my life. So up to that point, I had been just working in industry, bounced around all different kind of just basic stuff. I was doing a lot of Windows desktop programming, like Visual Basic, and then I got into Delphi for a while, kind of client server stuff, learning lots about databases. That's been an integral part of everything I've done from the beginning is using databases. But it was all just basic stuff, order systems, customers, the bank account kind of stuff, just your normal fare. Then I got a job at Boston.com, which was really cool because it was kind of a bigger platform, but it was still kind of the same basic stuff. It was news and entertainment instead. And then my boss at Boston.com was a technical reviewer on a book for a guy named Lincoln Stein, who was a big Perl author, like both modules and books on Perl. And I saw that Lincoln was hiring. I didn't know anything about him apart from what he had done in the Perl community, which was rather big at the time. He was kind of a big deal. And so between the connections there, but my boss knowing him, I was able to get my foot in the door at Cold Spring Harbor, which is Cold Spring Harbor is this little whaling village from the 1800s out on Long Island. Really cool little spot. And it's got this world-renowned campus for doing biomedical research. Anyway, I got a job working for Dr. Lincoln Stein there. Amazing Perl guy, but I had no idea of his work in biology. He's an MD PhD from like Harvard, MIT, super brilliant guy. He now works for the Ontario Institute for Cancer Research. Just like he got his start in human genetics. He started working in mouse models. Then he started working in plants. He was extremely renowned for working in these tiny, tiny worms called nematodes. He created this thing called wormbase.org. It was one of the first websites devoted to bringing together all these resources for community of researchers, like literature, and he helped write what's called a genome browser. So as we're there were a lot of studies in all kinds of organisms, tons of data. A lot of it just like would fit into an Excel spreadsheet, and these little kind of maps that they would create. Like they were able to figure out the chromosome structure and generally where on a chromosome where they thought maybe these particular traits were, but the world exploded in the 90s when we started getting into sequencing. So we could actually look at base by base the composition of chromosomes. And in the early days, it was incredibly tedious and expensive. It costs like $10 billion to do the Human Genome Project. We can do that project today in it took like 10 years, $10 billion. Now we can do the whole thing in like probably a couple of weeks and a few $1,000s. It's just absurd how far we've come. But in the early days, there were these maps as they were creating them, and you needed a way to visualize them. So he created a software called Generic Genome Browser that would just load up this data. And in the early days, they were still very small data sets, but you could visualize them in a web browser. You could look at these images to see where all these features were on the chromosomes. And so he brought all this together to create these websites for what are called model organisms. So things that people study there are these communities around, like say Drosophila, which is a fruit fly, worms, nematodes. They're in plants. There was a very, very small plant called Arabidopsis, phaeocress, and it's very, very easy to grow in a growth chamber. It grows very quickly. It's very understood. It has a small genome. There are these organisms that people study because it's easy to mutate them. They have short life cycles. You can look at how a mutation changes. Yeast, obviously, people study that. It's very, it's an extremely single-celled organism, and it's fairly easy to grow in a lab and study. And so I learned all this. I had no idea. I the last biology class I had was in high school. Actually, I was just visiting with a high school friend a couple weeks ago when I went home, and we both talked about this teacher, this high school teacher, biology teacher. We hated her. She was a terrible teacher, and it was like that. I dropped her class because I hated it so much, and like that, it left a bad taste in my mouth for biology. I'm like, I don't ever want to do biology, which is really a shame. When I think about teaching, I think at least I don't ever want to be that kind of teacher, right? That like turns someone off from programming forever. But so it was really wild that I ended up in this bioinformatics. So, for the longest time, biology had no need for computer science because the data sets were very small and they were just doing what's called wet lab stuff. So, actually in a laboratory with like pipettes and agar, in petri dishes and all that kind of stuff. But then once sequencing came along, we started having data. And it started off as a drip, a little bit of data that would take months to get. And then we started getting sequencers that would automate that stuff and start creating a lot more data. And I remember I started my early genetic maps that I was working with had like 30 features on a chromosome. And I kind of blew my mind when this thing called a fingerprint contig came along. And now all of a sudden I have 300 features on a contig, and I'm like, oh wow, that's like 10 times greater. And then we started getting bigger maps it was like 3,000. I mean, it just kept growing by orders of magnitude, right? And all of a sudden, I'm just swimming. I'm trying to cram this data into a MySQL database, and I've got 50 million rows, and like I'm just starting to scratch the surface. And I'm like, I was just like, it was blowing my mind how much more data I was getting every year after year. But so with the advent of sequencing technologies, biology has become this huge data science and has a huge need for people who are trained to computer science. And so you get this thing called bioinformatics, which sounds cooler in French, bioinformatique, because informatique in French means computer science. So bioinformatics is the combination. And usually what you'll find is someone like Lincoln, who is trained as a biologist who learned programming, or someone like me who it's pretty loose to say I was trained in computer science, but I came from computer science and then learned the biology. Nowadays, you have young whippersnappers going to school and studying both, right? Like when I was in high school, this wasn't even a field, right? I graduated in 1990. So there was no such thing as bioinformatics then. It grew in the 90s. And Lincoln basically helped create the field. So now you have people who are like, oh, bioinformatics, that's a cool field. They go in and they study like a double major in biology and computer science, and they kind of bridge the gap themselves, through their learning. Sometimes you actually have bioinformatics programs at some place where they're formally saying, here's the biology and here's how the computer science and here's how they influence each other. But a lot of times you're learning each field individually and you kind of synthesize it yourself. So I had no idea what bioinformatics was. I fell into it. I got the job in the lab because I was a web developer, because I was a Perl guy and I knew databases. And so Lincoln asked me to create this thing kind of like a genome browser. Genome browsers generally show you horizontally a small section of a chromosome. He wanted to see vertically whole chromosomes laid out next to each other with like large scale rearrangements. So you'll see this in chromosomes where, like, you probably know this, like when the mom and dad get together, there's a bunch of recombination to create. So there's a mixing, like you get your mom's nose and your dad's eyes. That's how that happens. And so you get these genetic rearrangements all the time in plants. And so he wanted to be able to see at a high level, this section of this chromosome got split between these two other chromosomes and got turned upside down, and all these things happen. And I was like, it was the hardest thing I'd ever done in my life. I couldn't believe what he was asking me to do. And the problem is that he could have done everything that he was asking me to do 10 times better and 5 times faster. But he was a busy guy and he needed me to do it. And so I was just like, it can be difficult working for like certified geniuses. That's what I'm going to say. So it was extremely hard. I worked my tail off for many years just to get my head above water. And then after I got comfortable with the domain and the comfort is still, I'm barely comfortable. I mean, it's such a deep field that I always have imposter syndrome. And I think and I talked about this with my current boss, like having been a self-taught programmer, having been a self-taught biologist kind of person, I just feel like I have always felt there are huge gaps in my understanding. And I always, even to this day, after 25 years of programming and publishing 3 books, I still have imposter syndrome. So, but that's how I got into this. And you get to a point where you're like, oh, I'm actually contributing to this field now. I don't want to go back to writing customer orders systems and working in just basic industry. So I decided to stick with this. I got my master's degree while I was working, Master of Science, while I was working at the University of Arizona. And that really helped to fill in, to backfill those gaps. Like I had never had a statistics class. And so, in science, we talk about p-values all the time. And I was like, I have no idea what a p-value is. And so now I do. It's really cool. So that's how I've gotten to where I am now. But even in my role now, like I don't do research. I help researchers who have a question, and I implement that for them. But I'm constantly going back to a researcher and saying, now, what did you mean by this? When how do you want this transformed? I still have a very, very basic understanding of the data that I work with.
What would you say are the 3 most valuable skills for someone in your role? Someone who works with a researcher, then builds technical solutions for that researcher.
There was a guy who I worked with who was a far better programmer than me. But one of the things that he always insisted on was a spec document before he would start writing. And I get it. I understand. And actually, I tried to get a job teaching at the University of Arizona in their software engineering program. And it was one of the things they dinged me on was the fact that I never brought up a spec document. Like, where does that figure into, how you would teach? I'm like, you know what? In my career, I've basically never had a spec document. Not really. I think one of the most valuable things that I have relied on in my career is prototyping quickly. So somebody says, here's something I want. And it's generally hand-waving, vague, maybe an email, a lot of times a phone call. Here's kind of what I think I want. Here's some input files. Okay, I will implement something that does, the MVP, minimal viable product. What is the simplest, quickest thing that I can deliver that does the first step? And then iterate from there. Actually, there's some interesting people I follow on Twitter, and somebody was just like, stop trying to come up with software estimates. It's a losing proposition. Just basically, I guess, I didn't get deep into what they were suggesting, but I think it was basically iterating. Like, try to create something that does something. Now go from there. And so I would say number 1, that's probably what has made me successful, is that I'm willing to just go out on a limb. And if I write something that's not even in the ballpark, okay, throw it away. I spent 2 days on that. It's not a big deal. I'm not going to go 6 months down a rabbit hole and then come back with something that doesn't work. right? I'm just going to go back to the person who has the domain knowledge, and I'm going to say, here's what I've got. Let me show it to you. And a lot of times with documentation, with pictures, with graphs, and then we can figure out, am I on the right track? And so that also just being able to communicate with people, whether like however they're comfortable. That could be email. In my current situation, like my boss isn't, so I'm in Tucson, Arizona. My boss is in Dublin, Ireland. We were working with this company that was in Australia. And so we were like literally spanning the globe from like trying to figure out like communication. Like I would talk to my boss, he would talk to the customer, and it would come back to me. And so I've never spoken to the customer directly. So I'm getting all this through an intermediary, but whether that's chat or email or phone call or video call, just being able to talk to somebody, hear what they're trying to, like, I think it comes down to storytelling. Really, going back to my roots as in literature, there's a story you're trying to tell, and we talk about this a lot with data in science. Like, okay, we have this data set. One of the best classes that I took in my master's essentially taught me how to read a scientific paper. And really, in learning how to read a paper, we started with the graphs, and then I realized that's where you start writing a scientific paper. A lot of times, is that you're trying to create a picture that is the story that you're telling. And then you fill it in with words. So like, what is the story? What is the purpose of this thing that we're trying to create? And it's kind of almost like therapy, right? It's like, you think this is what your problem is, but not really. Like, actually, personal story, and I think this is important. Just in a general point, I was really struggling with mental health for several years. It was difficult. I became convinced that I was depressed, like I had depression. So I finally sought a psychiatrist, and I said, I think I'm depressed. And he said, describe what you're going through, and I did. And then he came back. He said, I think you have anxiety, and because of this, your personality type, and I think this pill, it was an SSRI, selective serotonin reuptake inhibitor. He said, I think this will help. And it did help. And so, just as a side note, I think a lot of us in this field are probably somewhere maybe on the autism spectrum, maybe struggle with like intimacy, working with people. And so if anyone listening to this is having problems, please reach out and talk to somebody. But, sometimes you think the problem is one thing and somebody can help you see that it's actually a different problem and that there's a different solution that you haven't seen before. So, sometimes somebody may come to you, they're like, I want this program written. And you're like, what is the problem you're trying to solve? And then when you understand that problem and you understand the story, then maybe you realize, oh, there's a much simpler thing. Like, oh, we can just put this into a database, and that's an SQL query, right? I work with somebody who's not like an SQL person, and so they do a lot of stuff with pandas and data frames and stuff like that. And I look at this code, I'm like, that's really, really complex. I think it's much, much simpler if we just load it into a database and use SQL. So the first one was prototyping quickly and just like using that to refine what people are looking for. The other is like communication, like try to figure out what is the thing that's trying to be solved here. Third, I don't know, just I talk a lot. Is that useful? I mean, I have no problem expressing myself, and maybe that's rare in this field. I was not very comfortable when I first got up in front of a classroom. And this is an odd thing about me. You certainly wouldn't know, but I am actually an ordained minister. And the reason is because my sister-in-law was getting married several years ago, and she asked me to perform her ceremony. So I did an internet ordination. It's nothing serious, but I performed her wedding. And I was very nervous. I'd never done that. I had never done any acting, but I'd always kind of been like enamored of it. And so I did perform the ceremony. The people at the bed and breakfast where it happened, they said, hey, you weren't terrible. Would you like to be a person who does this at our place? And I was like, I don't know, I guess, sure. And so I just always, I approached it like it was a role, like it was something I was acting. And so I kind of forced myself when I got into the classroom to just, okay, I'm pretending like I'm a person who knows what the hell they're doing, who knows how to teach, which I did not at all. There was so much to learn with teaching. And so maybe a willingness to kind of put myself in very uncomfortable situations, like honestly going to work for Cold Spring Harbor and learning biology and doing that first piece of software for Lincoln, that was huge. I mean, I can't tell you how stupid I felt. And I have been willing to make myself feel extremely stupid over and over again because I'm just willing to essentially get in over my head and just trust that I can swim.
Yeah, I could not agree more on the getting out of your comfort zone comments. You mentioned imposter syndrome, and I think that if you don't have imposter syndrome, you're not going hard enough. You should be surrounded by people that make you realize that you have so much to learn. Of course, you can, if you're the type of person that likes a steady job where you can coast, more power to you. But I often find that if I am not feeling like the dumbest person in the room, at least the majority of the time, I get bored, and it's really hard to maintain interest. And also, the fastest way to grow is just surround yourself by talent and by really skilled people that know what they're doing. When you make a mistake, I'll never forget on my first internship, I had a call with my boss, like an intro call. And he was like, "Oh, what have you worked on in the past?" And I was like, "Oh, I've coded in Python and R. I use NumPy a lot," mispronouncing NumPy. And he slightly corrected me. And I will never forget the feeling of embarrassment. And I just didn't know, because I had always read docs. I'd never said the word NumPy before. So being able to get out of your comfort zone is an incredibly valuable skill, especially, as you said, for people who tend to be more introverted and technically minded and maybe less social. If you're willing to step out of that stereotype, you really do bring a lot more to the game than a lot of your colleagues.
Yeah. I
was just going to recap the other two. It sounded like prototyping is a very valuable skill that I am trying to work on as well. It sounds like the main value add from prototyping that you mentioned is that you don't waste time. Is that correct?
Waste as little time as possible. So I have a way that I now, I work probably in Python 90% of the time, and have for several years. There was a point at which I was like, okay, Perl had its day, but scientific computing is pretty much dominated with Python. So I moved all my tooling over to Python. It took me a while to figure out how, because I had a style in Perl, and I had to figure out what my style was in Python. I have actually a PyPy module called new.py. You can install it with new-py, but that's how I start every single command line program, which is 100% of what I do in Python is command line programming. And so I use that to start, and it always has the same structure. I use argparse, and then I do stuff with the arguments. So the first argparse is to me kind of like the shield, right? It's the interface to the command line, and make sure I'm getting some decent inputs to my program. So I have that, and then I say, okay, the first thing I need is this input file and maybe this variable. And I write that, and I do something with it. Maybe I write some tests, or maybe I just kind of eyeball it like, okay, this seems to work. And then I add the next thing. I don't write hundreds of lines of code and then run it. I write something, I add 2 or 3 lines of code, and I run it, and I look at it. And this is how I try to teach my students too. It's amazing to me how you will get a new programmer who will sit there and write 50 lines of code, and at no point syntax check, or just see if it runs, or use a code formatter to clean it up. They just write a bunch of stuff, and then they have 16 errors to fix. So try to get it to where, you're just constantly iterating. You're running it, you're checking it. Make files. Oh my God. If anyone hasn't explored just using make files to automate, I've got this complicated command line structure with all these arguments, just put that into a make file, call it run, put it at the top, and then you just type make, and it runs your program with all those things, and you look at it. And that's how I automate my testing too, make test, and it runs all these tests for me. And so you just come up with something that uses just a portion of the inputs and does something. Then add the next feature, then add the next feature, and constantly go back and see, are you on the right track? But, I would never spend more than a couple of days working on something before I would go back and ask my boss if I'm on the right track.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Yeah, and for a lot of people, rabbit holes are fun. So having the discipline is very admirable. I've gotten stuck down week-long rabbit holes, and then look up and realize I've done absolutely nothing and just wasted a bunch of time. So
yeah, it wasn't wasteful. You probably learned something. Maybe if nothing else, you learned not to spend a week before you raise your head.
Yeah, we'll go with that.
Cool. So that was point number one. And then finally, we talked about the third point, but point number two was communicating. And it seemed like the angle for communication from your perspective is to find the most efficient path to value and determining value, because often a lot of the stakeholders that you're working with don't know exactly what they want or even what is out there in terms of the solution space. So if you can communicate, read between the lines, find their problem, and then use your knowledge to try to solve that, that's a really valuable skill. Did I interpret that correctly?
Yeah, I would say that's it. Yeah, it is amazing, actually. Even in the bioinformatics space, I am now working with, when I was in academia, I was mostly, I was really working with researchers, principal investigators, people who write grants, and their grad students or their undergrads even sometimes. And so like the scale of problems that I was working on was kind of small. And now I'm working globally with, companies and all across, the world, and of all different kinds of sizes, from like huge mega pharmaceutical companies to small kind of startups with, maybe a dozen scientists. And like they have a lab technique, but they have no idea computationally what's available. Like they're like, okay, we've got this data and this is what we want to discover from it, but we haven't read any papers and we don't know what any of the tools are. And you're just like, oh my God, I'm not here to do your science for you, but still, I am here to hold your hand and give you an idea. So you're like, okay, so what is it you think you want? And it's my job, especially in a pre-sales role, to throw something together, show them how it works on the platform and say, okay, here's your input file you gave me and here's the output that I can generate for you. Are you ready to sign a contract, right? And then we can go from there. We have professional services who have, people with PhDs who can put this stuff together better than I can. But yeah, I deal with that a lot. People who really just have no idea what is out there in the solution space, certainly don't know a thing about cloud computing or databases or any of that. They have something and they think they want something and like, can you help me get there? And you're like, for the right price, yeah, I can, Yeah,
it sounds like a really fascinating role and a mix of a lot of different skills. Cool. So we are running a little bit low on time, so I figured we could start wrapping up. Any concluding thoughts? Any books you wanted to mention / re-mention? Any ways that people can get in contact with you if they so choose?
Yeah, it's funny. I put my email address in all my books, like just in the source code. It's everywhere. kyclark@gmail.com. I don't care. And not that many people write me, so it's not a big deal. I don't really, no one's ever abused it. I'm on Twitter, KYCL4RK. I was just a little bit late getting to Twitter, so I had to substitute the A for the 4. But I'm KY Clark on GitHub. I'm KY Clark basically everywhere that I could get it. So I've written 3 books, and they're really all about testing. And I think that no matter what you do, no matter what language you're working in, you should consider writing tests. I think it helps you break big problems into small problems and have confidence in your code. And tests. I was actually kind of having a discussion on Twitter the other day. Somebody was saying tests don't work. I don't like tests. I'm like, and they were complaining because they were trying to add something to an existing database code base that had a bunch of tests, but a bunch of the tests were wrong. They kind of sucked. And I'm like, well, code has to be refactored, and so do tests. I mean, it's constant. They co-evolve with each other. But like, if you're not testing, honestly, what are you doing? Like, how do you know that your program works? It's unconscionable to, especially in the scientific realm, to release something that has no tests at all. So test. Oh my God, please just write a test. I was working with this one guy at the university, and like, it took like 6 months. I was like, dude, write a test. And I kept showing him like with his code. I'm like, here, I wrote a test. This function doesn't do what you think it does. And he's like, oh, I'm like, doesn't this bother you? Oh my God. So I don't know. I guess that would be the thing I would say. And if you don't know how to write tests, I've written 3 books, 2 in Python and 1 in Rust, that will show you how to get started with that. But the ideas you can take to any other language. And honestly, if you were to read the Python book and one of the Python books and one of the Rust books, you would see I'm doing the exact same thing. I just cargo culted those ideas over. I'm like, okay, how do I get started parsing command line arguments using a standard module, and how do I test? And that's essentially like 80% of what I do.
You hear that, people? Test your code, please.
For the love of God, test your code.
For the love of God. All right. Well, this has been really fun. It's been Michael Berk and Ken Youens-Clark, and we will see you guys next time. Thanks.
Thank you.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.